Hello students, welcome to my YouTube channel Rapid Chemistry. I am Ranjan Das, would like to discuss a very new chapter for ICSE class 10 and that is electrolysis. Electrolysis, this is the sixth chapter of ICSE class 10 book and we will discuss this chapter taking reference of the book this one that is Concise Chemistry class 10 latest edition. Okay, let's open the page number 101. 101 electrolysis. At the very first, let's see introduction. So introduction, as it says, electrolysis, and if you divide the term electrolysis, we are getting two terms of meaning electro and lysis. Electro means related with electrons or electricity, and the lysis means separating, that is bringing about a chemical change. That means in this chapter electrolysis actually means bringing about a chemical change at the cost of electricity. Now the question arises, which type of compound or substances will undergo electrolysis? So for that we have to know that generally the metals can conduct electricity, but the metals or elements, they will not go electrolysis. Electrolysis are generally possible for the compounds, chemical compounds, and which having ions in the molten or aqueous stage. That means the compounds which will have molten at the molten stage having ions, that is cations and anions, and they will undergo electrolysis. And all those substances which will give cations and anions in the aqueous or molten stage, and those are actually said to be electrolytes. Okay, electrolytes. So, and the substances which will not give ions in the aqueous or molten stage, like covalent compounds, sugar solution, can you see here, sugar solution or sucrose solution, and they are non-electrolytes. That means electrolysis is a change and which can occur at the cost of electricity, and the electricity, and it is for your information that what kind of electricity that can cause electrolysis, and that should be DC electricity, direct current. At the cost of direct current there can be a chemical change, and the chemical change and the compounds for which electrolysis can be possible, and those are said to be electrolytes. Okay, and the compounds for which electrolysis is not possible, and they are said to be non-electrolytes, and the examples are there. In electrolytes, all the compounds which will give ions in the aqueous or molten stage, like as given here, for example the passage of electric current through copper chloride solution decomposes to metallic copper and chlorine. And electrolysis bringing about change at two rods, the metal plates, and those are called cathodes and anodes. Okay, so let's move to the very next page, and here page number 102. So at the page number 102, let's see the comparison between metallic conductors and the electrolytic conductors. The both will conduct electricity, but the electrolysis will occur for the electrolytic conductors. And the metallic conductors means the metals, that is copper, silver, gold, iron, aluminium, which conduct electricity. And for these type of conductors, actually metallic conductors, the electricity flows due to the passage of free electrons. They having free electrons, and those free electrons are the responsible for conducting electricity. But in the electrolytic solution or electrolytic conductors, the conduction is possible due to free ions, cations and anions. And you know, positive ions are called cations and the negative ions are called anions. The metallic conductors and the electrolytic conductors, their comparison is given here. And one more important comparison, as I can say. So with increase in temperature, for metallic conductor resistance increases, but for electrolytic conductor resistance decreases. Okay, so there are some common properties are there. So whenever electricity flows through metallic conductor, physical changes are there, but here chemical changes are there. When the electricity flows through the metallic conductor, the mass or substance is not moving, but here the mass or substance is moving. So these are the common comparison between the metallic conductors, and here as example copper wire is taken and the electrolytic conductor copper sulfate solution. Now let's come to the point, the definition, electrolysis and electrolytes. Electrolysis and electrolytes. Electrolysis. It is the process of decomposition of a chemical compound in aqueous solution or in molten state accompanied by chemical change by using direct electric current. I have said these points. And the substances for which electrolysis process is possible, and those are said to be electrolytes. And here as it says, electrolytes are compounds which either in aqueous solution or in molten state allow electric current to pass through them. Okay, the electrolytes are molten salts of solution of salts in water or solutions of acids in alkali. Okay, now we will go through the different kinds of electrolytes. Electrolytes can be acids, it can be bases, it can be salts. Acids means H2SO4, HNO3, and you know the name of the compounds: sulfuric acid, nitric acid, phosphoric acid, hydrochloric acid. Among the bases, sodium hydroxide, potassium hydroxide, ammonium hydroxide, calcium hydroxide. Among the salts, sodium chloride, copper sulfate, lead bromide. Okay, so there are different type of compounds which will undergo electrolysis. So there may be acids, there may be bases, there may be salts. But one thing must be common out of all these, that they must produce ions in the aqueous or molten stage. Among all these electrolytes, there can be electrolytes which will conduct more current. That means they will ionize completely, and those are said to be strong electrolyte. And there are some electrolytes which will not conduct electricity more, less amount of electricity they will conduct. They are said to be weak electrolyte. And it has been found strong electrolytes are the electrolytes which dissociates almost completely. But for weak electrolytes, they dissociate partially. Okay, let's see their comparison as given on the same page 102 of your book. Okay, come to here. Strong electrolytes and weak electrolytes. As I have just said, the strong electrolytes which allow large amount of electricity flow through them, but weak electrolytes which allow small amount of electricity to flow through them. Strong electrolytes are good conductor of electricity. Weak electrolytes are poor conductor of electricity. Strong electrolytes are almost completely dissociated in fused or aqueous solution state, but the weak electrolytes partially dissociates in fused or aqueous solution state. Strong electrolytes contain almost only free mobile ions, and this solution contains ions as well as molecules, as it is not completely ionized. Strong electrolytes allow bulb to glow brightly, but the weak electrolytes allow bulb to glow dimly. And the example of strong electrolytes given here, can you see? The hydrogen chloride, that means hydrochloric acid, it would be in the aqueous stage. Sulfuric acid, nitric acid, sodium hydroxide, potassium hydroxide, aqueous or molten. Salts, that is NaCl, molten or aqueous. Lead bromide, it should be molten. Copper chloride, aqueous. Copper sulfate, aqueous. Aqueous means the solution in water. Okay, so they all strong electrolytes. And about weak electrolytes, they are the weak electrolytes because they ionize partially with less amount of ions produced in the aqueous or molten stage. Okay, so these are the weak electrolytes. Hopefully you got what strong electrolytes and what are the weak electrolytes and their behavior and their examples. Okay, now we'll move to non-electrolytes. And the non-electrolytes means the compounds which for which electrolysis is not possible at all. It is compound which neither in solution nor in the molten state allow an electric current to pass through it. It also does not decompose at the electrodes. Now there are many non-electrolytes are there, and you have to know the name of all these: distilled water, alcohol, kerosene, carbon disulfide, cane sugar, benzene, glucose, urea. They are all covalent compounds and they having no tendency to ionize in the aqueous or molten stage, and they are treated as non-electrolyte. Okay. Now we have already understood that the electrolytes can be acids, it can be bases, and it can be salts. And it is not necessary that for all the electrolytes it will ionize completely or 100%. There may be partial ionization. So we'll learn one term here, and that is said to be degree of dissociation. Degree of dissociation. Okay. Look at here at the bottom of this page number 102 here, degree of dissociation. And what does it mean? Number of molecules dissociated to total number of molecules into 100. Okay, taking one example, I can clear it what degree of dissociation is all about, and it is expressed in terms of alpha. Just for understanding, say you took an electrolyte and 1000 molecules of electrolytes are taken, and out of those 1000 molecules of electrolytes, and you got 5 molecules undergoing ionization. Then you can find out the value of alpha, that is degree of dissociation, and that would be 5 by 1000, and the value is 5 into 10 to the power minus 3. And for weak electrolytes its value is very less, but for strong electrolytes its value can be almost or close to 1. Okay. Now we shall go through this chart, and this chart is all about acids, base and salts. That means the electrolytes. So all the acids, bases and salts, they can be strong, weak, strong, weak, strong, weak. Okay. So all of you have to remember the strong acids, that is the strong electrolytes, strong bases, strong electrolytes, and the strong electrolytes, the salts. But among the acid, bases and salt, they are weak, weak, weak. And just try to remember the examples given here and the process of ionization and how they are ionizing. Okay, how they are ionizing, you have to know their process of ionization. And one thing we have to remember, so for the strong electrolytes, okay, so ionization is almost complete. That is the value of alpha having value almost close to 1, but for the weak electrolytes the alpha having very less value. Okay, generally for weak electrolytes there may be maximum 5 to 10% ionization. The rest molecules are in the form of non-ionized state. Okay, say for acetic acid in solution, as it is a weak electrolyte, so it will ionize like this, acetate ion and hydrogen ion. So in the solution you will get both acetic acid, acetate ion and the hydrogen ion. But for strong electrolytes the most possibility is you will get only ions, because it will almost completely ionize. Okay, so now we'll move to the very important part, that is electrolytic cell or voltmeter. Electrolytic cell or voltmeter is the device in which electrolysis is actually carried out. The total arrangement here. Okay, so here just try to observe that one container is taken and the two metal plates are there. One is attached with positive terminal of the battery and another is attached with negative terminal of the battery, and the plate which is attached with positive terminal of battery or the DC source, and that is said to be anode. Okay, do not confuse. And the negative terminal of the battery, it is attached to another rod, and that is said to be cathode. And these are said to be the plates or the electrolytic rod here used, and the electricity here used, and that should be DC electricity. Okay, so now let's go through what is written and here in italics. what is electrolytic cell? A non-conducting vessel. It is a non-conducting vessel L containing two electrodes. These are the two electrodes, cathode and anode, combinedly called electrodes. Okay, immersed in a solution of electrolytes. Yes, they are immersed in a solution of electrolytes used to bring about a chemical change. Yes, whenever electricity will flow there will be chemical change at the surface of cathode and anode. Okay, and at the cost of DC source. Okay, so that is the electrolytic cell in which the electrolysis is carried out, and that is said to be voltmeter, not voltmeter. Okay, it is voltmeter. Okay, now let's move to electrochemical cell. That is not there in our syllabus actually, but you have to know electrochemical cell is a device used to convert chemical energy into electrical energy. That means where you will get electrical energy at the cost of chemical energy, but here the opposite thing in the voltmeter here. Electrochemical cell can be simple voltaic cell, Daniell cell. Okay, so electrodes. What are the electrodes? Those the plates which are immersed in the electrolytic solution, and those are electrodes. Two electrodes are there, cathode and anode. Okay, and do not forget, anode is attached to its positive terminal of the battery and the cathode is attached to its negative terminal of the battery. And here definition is there for the electrodes. Just to go through it very fast. Electrodes: two metal plates or wires or graphite rods or gas carbon rods immersed in the electrolyte through which the current enters and leaves the electrolytic cell are called electrodes. Okay, so the electrodes can be cathode and it can also be anode. Okay, so I have already said what are the cathodes and anodes. Okay, now let's move to the comparison in between or differences in between cathode and anode. Okay, so only 3 points are there. Just to go through once and you will see these are already discussed. Okay, and here one important point. So in anode, anions migrate to anode and the cations migrate to cathode. And why it is so? The cations migrate to cathode because cations are the positively charged, and the positive charged particles move towards negative electrode, and the negative electrode is here. We got the negative electrode is here. Can you see? The negative electrode is cathode. So at the negative electrode, cations will try to discharge. Next here is ions, and ions, the atom or atoms or groups of atoms which carry a positive or negative charge are known as ions. Okay, let's move to the very next page here, and it would be page number 104 of your book. Okay, so what is there at the 104? So differences between cations and anions are there. So what are the cations and what are the anions? Okay, so cations are the positively charged particle and the anions are the negatively charged particle. And the examples are given. You just go through all the examples very carefully. Sodium, calcium, aluminium cations, phosphate, chloride, sulfate, hydroxyl. Okay, phosphate, chloride, sulfate and hydroxyl, these are the anions. So cations are the positively charged. They will have the tendency to discharge at the negative electrode, and that is cathode, and that's why it is said cations move towards cathode and the anions move toward anode. Now one question is raised, and that is electrolysis is a redox reaction. And why? Because in electrolysis, reduction and oxidation both occur simultaneously. Okay, so it has been found. So oxidation occurs. You know what is oxidation? Oxidation is the loss of electron. Okay, that means whenever metals releasing electron to become positively charged particle, okay, or neutral if it is anion, that means loss of electrons are there. It is said to be oxidation. Okay, and oxidation can also be like this. Addition of oxygen can also be oxidation. Removal of hydrogen, that can also be oxidation. So now let's go through few oxidizing agent, and here given on the page number 104, right column at the top. And here, can you see the liquids, solids and gases, the oxidizing agents are there. Manganese dioxide, red lead, you know the formula of red lead, Pb3O4, Pb3O4. Lead dioxide, PbO2. So these are the solid oxidizing agent. And the liquid oxidizing agent, hydrogen peroxide, H2O2, concentrated nitric acid, sulfuric acid, bromine, Br2. So these are the liquid oxidizing agent. And the gaseous oxidizing agent, so these are the oxygen, ozone, chlorine, sulfur dioxide. So here we came to know what oxidation. Oxidation means loss of electron. Okay, it means addition of oxygen, and it also means removal of hydrogen. And we also learned that there are different kinds of oxidizing agents like solids, liquids and the gaseous with their examples. Now what reduction? Reduction is the just opposite thing here. That means the ions whenever taking electron, and the process is called reduction. And removal of oxygen, that is also said to be reduction. Okay, adding of hydrogen, addition of hydrogen is there, that is also reduction. And reducing agent, and here at the bottom reducing agents, and there are some examples of solid, liquid, solid reducing agent, carbon, metal like zinc, aluminium, copper, SnCl2, these are the solid reducing agent. Hydrogen peroxide, hydrogen iodide, hydrogen bromide, these are the liquid reducing agent. And the gaseous reducing agent is there at the page number 105 at the top. Okay, gaseous reducing agent, see here, gaseous reducing agent, hydrogen sulfide H2S, carbon monoxide, sulfur dioxide. So all of you have to remember solid, liquid, gas oxidizing agent and the solid, liquid, gas reducing agent. And we'll definitely discuss why that is the electrolysis is a redox reaction. Because at cathode reduction occur and at anode oxidation occur, and how I will discuss step by step. So theory of electrolytic dissociation was given by the scientist Arrhenius as early as in the year of 1887. Okay, so some basic idea is given regarding electrolysis. So what electrolysis is already we know a bit, and these are already here summarized. You just read and you will find these are almost known to you. The first one, an electrolyte on dissolving in water dissociates into free mobile ions, that is cations and anions, and allow the flow of an electric current through it. All ions carry an electric charge and are responsible for the flow of current through the solution. The conductivity of the electrolyte depends upon the concentration of the ions in the solution. So there are some basic understanding and some basic concept is given regarding electrolytic dissociation, and you just read out all this. Hopefully you will understand, and if not, definitely knock me here. Okay, so now the characteristics of electrolysis. We will understand the characteristic of electrolysis taking one example at the page number 105, right column at the bottom. Say the electrolysis of aqueous NaCl sodium chloride is carried out. What will happen? So at cathode sodium ion you know, so take up electron to Na, that is a reduction process. At anode the chloride ion loses one electron to form Cl, and 2 Cl combine to form Cl2 gas. Okay, so what is the overall reaction? NaCl changes to Na and Cl2. So here I think it should not be aqueous, it should be molten. Okay, molten NaCl produces only ions. If it is aqueous, there will also be hydrogen ion and hydroxyl ion, so it should be molten. So molten NaCl whenever electrolyzed, we are getting sodium at the cathode and chlorine at the anode. Okay, and at cathode reduction occur, at anode oxidation occur, and that's why the process electrolysis is said to be redox reaction. Okay, and the overall reaction is given. And we have already discussed here the AC does not cause any chemical change. That means the electrolysis can also be carried out using DC electricity. Okay, Now on the very next page we will discuss electrolytic dissociation. As the term says, electrolytic dissociation, that means dissociation of a certain substance, and generally here electrolytes under electricity. So the definition is given here: the process due to which an ionic compound dissociates into ions in the fused state or in aqueous solution is called electrolytic dissociation. So how electrolytic dissociation of sodium chloride occurs, and it has been picturized, and can you see here sodium ion and the chloride ion, that is a electrovalent compound having electrostatic attracting force in between sodium cation and the chloride ion. Okay, in solid state the ions are held by electrostatic attraction. When electrovalent compound like NaCl are fused or dissolved in water, the oppositely charged ions becomes mobile and it will start conducting electricity. Okay, it will start conducting electricity and they will become free whenever that is sodium chloride is mixed with water or it is heated up. Okay, in aqueous solution NaCl, you know, the the electrostatic force of attraction in between cations and anions is no more there. They will get separated and surrounded by the water molecules, and then there will be the separation of cation and anion. They are free to move in the aqueous solution and electrolysis can be possible then. Now we'll move to ionization. Dissociation and the ionization, though these two are similar but not same. So ionization means the ions will form, but ionization term is applicable for generally covalent compound, and dissociation is generally applied for electrovalent compound. Okay, so dissociation and ionization, the ionization definition is given here. Can you see? The process by which polar covalent compound are converted into ions in water solution is called ionization. Okay, so how ionization occurs, it has been shown nicely here. So just to go through the comparison of ionization and dissociation. Ionization means, you know, formation of positively or negatively charged ions from molecules which are not initially in the ionic state. Ionic state, those are not in ionic state. But dissociation, separation of ions which are already present in an ionic compound. So dissociation generally like KCl, for KCl ionic compound, electrovalent compound, dissociation occurs, but for HCl, hydrogen chloride, it is for ionization occurs. They are not same thing. Now we have to do the in-text questions. After doing these pages, that is, we have started our discussion from 101. Okay, 101 electrolysis. So we have discussed up to page number 106, and at the page number 107 some in-text questions are there. So you all have to go through all these in-text questions. Okay, and if you have anything to say, if any problem arises, I will definitely help you. So in this unit, it only up to this. On the next unit we will discuss the next part of this chapter, that is electrolysis. Okay, bye.